All right. Notes for August 14th. Today we're going to start on page 7 in your composition book. If your class has already taken these notes, you can just kind of fast forward through and find where you need to start. But I think we've all done this where we've talked about the first 3. Remember when we did our spaghetti and our colored dot and our index card? Those were representations of the 3 fundamental concepts of geometry. And they're undefined terms because they're very difficult to define. So we use representations, drawings, and like those tangible things that we used in class the other day. So fundamental concepts that cannot be formally defined using other geometric terms. Okay, so what are they? Well, we have points. We have a point, a line, and a plane. And so how we symbolize those is a point, we use a dot, okay, that represents a point. But what a point actually is a specific location. You see this when you look at a map and there's a dot that tells you where the location of a city is, okay? A specific location. A point, though, here's the undefined part, the kind of confusing part. It has no size or dimension. Okay, it has no shape. We are just showing where something is when we put a dot there, but that dot is representing a point. It's representing a specific location. Okay. Now, lines are made of infinite number of points, okay? And it's a straight, I don't want to say a straight line because that's what we're talking about, but it's a straight path of, and I'm going to use the word, this infinity symbol of infinite points, okay? So it's infinite points all in a straight path. It goes on infinitely in the opposite directions of that path. There is no thickness to it. There is no width. Okay, well, how is that? Like when we draw the representation right here, okay, when I drew that representation, I could draw it a thicker line, a skinnier line, whatever, but I'm just drawing the representation of where the line is. So no thickness or width, and the reason that is because since it's made of points have no size or dimension, so how can something that has no size or dimension make up something that has a size and dimension, all right? So, like I said, kind of crazy. All right, a plane. How do we show a plane? Well, it's like a flat surface or something is what we think of. It's got infinite lines and infinite planes. But the best we can draw, we'll usually just put it looks like a parallelogram. And we've talked about how when they're named, they'll usually use a script capital letter to name those. A flat surface extends in all directions, all 4 directions. So if you're thinking of, your desktop or a paper, the plane, you can see part of the plane, but it extends in all directions. And it's not going to have any thickness either, okay? So very interesting descriptions of those things. I hope after our activity with the spaghetti, the index card, and the dot, you have a tangible idea of kind of what they are, okay? Because they're kind of abstract. All right. There are some rules that go with points, lines, and planes, and so we're going to go over these. There are different types of rules in geometry. You have postulates, which is this right here, and these are statements. let me not put the S there, a statement assumed to be true without proof. Okay. Assumed to be true without proof. Okay, and a lot of these will be common sense. So let's think about these, visualize these as we're filling these through. Okay, so the first thing says, through any 2 points, there is exactly one line. Okay, so if I drew 2 points here, I can only draw one line through those. Okay, there's only one line that will pass through both of those. Okay, so exactly one, only one. Okay, the second one says if 2 lines intersect. Okay, so if I have a line here, okay, and an intersecting line here, where do they intersect? They will intersect at exactly, and that just means only 1 point, exactly 1 point, where I drew my little dot there representing the point where they are, the point where they're intersecting. Okay. The third one, I'm not going to try to draw this one, okay? But if 2 planes intersect, their intersection is a line. Okay, if 2 planes intersect, their intersection is a line. And you'll see that in some of the drawings we'll look at in a minute. Number 4, through any 3 non-collinear points, there is, and the A should not be there, that's a typo. There is exactly one plane, okay? And the word non-collinear means not on the same line, okay? So three points, if I had a point here, okay? That could be on the same line, but the third one, does say three non-collinear points, they're not going to be on the same line, but they will be in the same plane. And then finally, if 2 points lie on a plane, then the line containing the points is also in the plane. Okay, also in the plane. All right, let's continue. All right, so the next learning target is I can model and name geometric figures such as angle, lines, rays, line segments, points, and planes. All right, so our other learning target previously was can develop and use precise definitions of figures based on points, lines, and distance along line. Points, lines, and planes, using those terms to define other geometric figures. So look what we're going to do here. Let's define a segment, okay? What a segment is it's just a part of a line, okay? Just a piece or a part of a line, and it has 2 endpoints. Okay? So endpoint is just a piece of a line, okay? So look at the definition I just wrote. We're using 2 line and points. We're using 2 of our undefined terms that we talked about on the previous page. Okay, so those are they're undefined, but they're used all over the place when we describe geometric figures like segments, rays, and angles. Okay, all right, what is a ray? A ray is part of a line. Okay, there's that word again, part of a line with 1 endpoint and extending, so not 2 endpoints, but just 1, okay? and it's in extending infinitely. Well, maybe we shouldn't do that. Extending infinitely. I'll go ahead and write it, or you can use a symbol. Infinitely in the other direction. Okay, so part of a line, got an endpoint, and then it keeps going in the other direction, so we'll need to put the arrow there. Oops. Okay, and lastly, angle. Okay, what's an angle? Okay, so watch me draw it real quick here. An angle, just like that, okay? An angle is formed by two rays that share a common endpoint. And that common endpoint that they share is called the vertex, okay? We'll talk more about those all the time. We'll talk about those a bunch. Okay, so segments, rays, angles, points, lines, planes. We've got 6 different things we have discussed so far, all right? So we are going to need to know how to represent them, so how to model them, and how to name them using symbols and notations, okay? So we have got one of each here. So we've got 6 things we're going to draw and name, all right? So line AH, okay? So I'm going to draw a line. And when we name a line, we're going to use 2 points. I didn't draw that very straight, so do the best you can, okay? 2 points, we're going to use the 2 points. If there's more than 2 points on the line labeled, then you can choose any 2, okay? So using 2 points on that line to label, or to name it, so line AH, okay? So the symbols for that, AH, and you put a line over it, okay? You can also call this line HA, HA, okay? So the order of the letters doesn't matter, but put 2 points of the line there and then draw a line with arrows over the top, okay? Next one, segment. So remember, that's a part of a line, ND. So ND, that's going to be those 2 endpoints that it has. Okay, so segment ND, you're going to use the 2 endpoints. Okay, if there's another point on that segment, I still want to use N and D. Okay, you're going to use the endpoints to name it. So ND, and you'll just draw that little bar over it. No arrows, because segments are just a piece. They don't continue, okay? Or you could also call it DN. Okay, so the order of the letters doesn't matter here. Okay, array, LE, that does matter. Okay, so remember, array has an endpoint. So the L is the first letter we list is going to be the endpoint, and then L, E, that E is going to be another point somewhere on that array, okay? But the L endpoint has got to be written first, and then you draw a ray above it, okay? So that L has to be first. That's going to be the endpoint. Write that first. Angle ABC. My first class was not sure about this. Okay, so y'all know what an angle looks like. All right, here's the thing. We're going to make that A, we're going to make that B, and that C. Okay, the vertex is always written in the middle. Okay, so the vertex where they meet, the two rays meet, is B, and so that's always going to be written in the middle. So there's really just, I can call this angle ABC, or I can call it angle CBA, okay? I can't use any other order of those letters, okay? I can also, though, just call it angle B. So it can be named just after the vertex, okay? The vertex is super important. Okay, I'm going to stop the video here. There's going to be a part 2, so y'all can watch that later.